Hello viewers, I think all of you are doing well. The videos which I have been presenting for you, mainly I have provided with you the videos for class 12 mathematics, but today I have thought of providing or uploading the video for class 11. Previously I had given a video for class 11 limits. The concepts of limit I had given. I did not show any example or much of limits, how to solve the limits or evaluate limits problems I have not yet discussed. So today I have thought of uploading the video for class 11 limits, how to solve the given limits. Actually this topic is very new for class 11 students, and sometimes they feel it confusing. If the concept is not clear, the students mix up and make it more confusing. So before going through the examples, I would request once again to see the concept of limit, which I have discussed in my previous video, so that you understand how to evaluate a given limit, what is the working rule for a problem of limit. Mainly I shall deal with the algebraic functions, the limit of algebraic functions. I hope you will understand and you will enjoy the video. If you enjoyed, don't forget to like and share my video and my channel. Please subscribe my channel and always request your friends to subscribe, so that more and more students can get the benefit from this video. So without wasting much of our time, let us move on to the examples. So our question is x to the power 4 minus 4 by x square plus 3 root 2x minus 8. X tends to root 2. This is an algebraic expression in the form of numerator by denominator, or in fractional form. It is a if I put the value of root 2, x is equal to root 2 here, what we notice is we will get here root 2 to the power 4, that is 4, minus 4, that will be 0. Numerator part will be 0, and denominator part root 2 square is 2, plus here if I put root 2, it will be 6. 2 plus 6 is 8, minus 8, that is also 0 by 0. Now let me tell you that after putting the value of x, whatever it tends to, if it is in the form of 0 by 0 or infinity by infinity, infinity to the power infinity, and all those types of things, then those things are known as indeterminate forms. Indeterminate forms. The forms or the expression which cannot be determined. So when we have of this type of forms, we try to factorize. We don't directly put the value, because this is something which is meaningless or something which cannot be determined. So we try to factorize them and cancel the common factors from the numerator and the denominator. So let us see how it is done. So limit x tends to root 2. You should not get confused or very panicked seeing so many roots and all those things. Be very easy to factorize. This is x square whole square minus 2 square. It is in the form of a square minus b square. Below we have 3 root 2 and 8. So we have to do the midterm. midterm of this will be x square. So 8, and here we should get 3 root 2. That means 4 root 2 and root 2. So it could be written as 4 root 2 x minus root 2, 4 root 2 x minus root 2 x minus 8. So this is further written as limit x tends to root 2 x square minus 2 x square plus 2 divided by x plus 4 root 2 and x, we take root 2 common here, x minus 4 minus root 2. So that its product is 4 2s are 8 and its sum is 3. So limit x tends to root 2. This can be again written as x square minus root 2 whole square. So this is x minus root 2 x plus root 2. Then it is x square plus 2. Below it is x minus root 2 and x plus 4 root 2. This gets cancelled. Now if I put the value of root 2, I will get root 2 plus root 2. And the root 2 square is 2 plus 2. Below we will get root 2 plus 4 root 2. So this is 2 root 2. Root 2 plus root 2 is 2 root 2. And 2 plus 2 is 4. By 5 root 2. Root 2 plus 4 root 2, that is 5 root 2. 5 root 2, sorry. This is 5 root 2. This is root 2 root 2 cancels. Below we will get, above we will get 8 by 5. Very simple. Only the thing is, we should do the factorization properly. If the factorization is correct, then ultimately you see the term which was providing 0 by 0, that gets cancelled and we get the finite value or finite number, and that is the limit of the function or limit of this whole algebraic expression. Let us see the next example. Well, this is a different type of question. Limit x tends to 3 x to the power n minus 3 to the power n by x minus 3 equal to 108. I have to find out the value of n. What is n? Okay. Now we know a standard limit, or one theorem is that limit x tends to a x to the power n minus a to the power n by x minus a is n a to the power n minus 1. I think this is known to you. If not, please note down limit x tends to a. This is known as standard limit, or this is one of the theorems where a is any number and n is also any number. So limit x tends to 3 here. So applying this, here a is 3 comparing n. So accordingly we get n into 3 to the power n minus 1 is 108. So n into 3 to the power n by 3 is 108. Now let us cross multiply. N into 3 to the power n is 108 into 3. Let us find the factors of 108. 108 is 3 3s are 9, 3 6 are 18, 3 12s are 36, 3 4s are 12. So this could be written as 3 to the power 3 into 4, that is 108, into 3, n 3 to the power n. Further, n 3 to the power n, or n into, that is, this is also into, this 3 to the power of 4 into 4, or 4 into 3 to the power of 4 is n 3 to the power n. Now comparing both sides, we see that n is, so this is the answer. So this has been done by the standard limit, or one of the theorems. Limit x tends to a, x to the power n minus a to the power n by x minus a is n a to the power n minus 1. Well, we have this question, fx is equal to 3x minus 1 when x is less than 0, equal to 0 when x is equal to 0, and 2x plus 5 when x is more than 0. What we have to calculate? First of all, we have to calculate limit x tends to 2 fx. Now we notice that how the function is defined. For the values of x greater than 0, x tends to 2 is what? We'll write it. We have to find these two things. We'll write limit x tends to 2. Greater than 0 means 2x plus 5. So this is, we put directly the value, because it does not give anything meaningless or indeterminate form. 2 into 0 plus 5. That is 5 is the limit of fx when x tends to 2. Now what about limit x tends to 0 fx? If you notice the function properly, you will see that the function is defined for x less than 0 separately, x greater than 0 separately. When it is less than 0 and greater than 0 defined separately, we should consider the left hand limit and the right hand limit, as I had explained to you earlier. Now, for this portion of the function, we have values of x. Suppose 0 is here, then this is the left side, values of x less than 0, and here values of x more than 0, approaching 0. So we find out left hand limit. Limit x tends to 0 minus fx. Limit x tends to 0 minus fx means 3x minus 1. Now when we have introduced the function, we write directly limit x tends to 0, 3x minus 1, that is 3 into 0 minus 1, that is minus 1 is the left hand limit. What is right hand limit? Limit x tends to 0 plus fx, that is defined here, that is limit x tends to 0 plus, or 0 directly we write, because we are going to put the function at this point or at the values of x greater than 0, that is 2x plus 5, or that is 2 into 0 plus 5, that is 5. What we notice? Left hand limit is minus 1, right hand limit is 5. This shows what? Left hand limit is not equal to right hand limit, implies limit does not exist at x tends to 0. So this is what is asked. What is the limit at x tends to 0 fx? Then you should write that limit at x tends to 0 fx does not exist. Let us see the next example. In this question, fx is equal to x minus mod x by x not equal to 0 and equal to 2 when x is equal to 0. What we have to do with this question? Show that limit x tends to 0 fx does not exist. We have to show here also that limit does not exist when x tends to 0. Now we need to redefine the function, because here it is not equal to 0. Not equal to 0, and here it is mod, so that's why we need to break up the function and get the values for x less than 0 and x more than 0. So it is like this way: x minus of minus x by x when x is less than 0, and x minus of plus x by x when x is greater than 0, 2 when x is equal to 0, or further 2x by x, and here it is 0 when x is greater than 0, x less than 0, 2 when x equal to 0. So this is further, this is 2, 0, 2. This shows that when it is left hand limit x tends to 0 minus fx will be 2, because left hand limit means we will put this value, and right hand limit is limit x tends to 0 plus fx, that is 0. This shows what? LHL is not equal to RHL. LHL not equal to RHL. Thus, limit does not exist. Limit x tends to 0, fx does not exist. I hope the questions which I had taken for explaining you were quite understandable by all of you. I suppose by these examples, if you go through these examples properly, the other problems of the book can be solved, and you can benefit from this video more and more. Thank you. Stay well. See you again.